Hi, this is Jeff from the Ozark Mountains. That's in Missouri, in the USA. Today, on the bench, we have a couple Tandy Portable Disk Drives. We have the TPDD1 and the TPDD2. Now, why these use a standard 800K 3.5-inch floppy disk like would have been used on the Amigas or Ataris of the time, the TPDD1 only stores 100K on these guys, but the TPDD2 stores a whopping 200K. What makes them unique is that they have an RS-232 serial interface and they run on batteries. Now, both of these guys need the belts replaced, and this unit here, which happens to be mine, is in pretty rough shape. It'll need some cleaning and refurbishing. This one, on the other hand, is in really good shape other than needing the belt, and it was sent to me by somebody else wanting the belt replaced, and I thought it would be a good time to look at the pair of them and see how they're the same and see how they're different. So let's jump right in. Thanks to PCBWay for sponsoring this episode. Whether you need a small simple board like this or a larger, more complicated design, head on over to PCBWay.com, click on PCB Instant Quote, upload your files, and select from the plethora of options available. PCBWay offers a wide range of products and services, including assembly, stencils, and PCB design. When you have a need for circuit boards, head on over to PCBWay.com and give them a try. Radio Shack debuted the TPDD1 part number 263808 for the Model 100 in the 1986 catalog for a retail price of $199.95. This gave your Model 100 a whopping 100K of fast storage through the serial port. Bootstrapping the M100 so it could talk to the drive was a bit tricky though. In 1988, the TPDD2 part number 26-3814 was in the Radio Shack catalog for the same $199.95. But it now offered a massive 200K of storage. It could also be used with the T102 and Model 200. While a portable, battery-operated, serially interfaced, and very low storage capacity 3.5-inch floppy drive might seem like an odd idea, it gets even stranger when you learn it was originally made by Brother for electronic knitting machines. The Brother FB100 and Knit King FDD19 are functionally the same as the Radio Shack units, but with a solid black case. It may be that the F100 indicates it's a 100K drive, and the FDD19 is the 200K version, but I have not been able to verify this yet. Being that the drive has a standard RS-232 serial interface with a voltage level converter built into the cable, it can, in theory, be interfaced with about anything. In fact, several PC-based clients have been written to allow using a PC to talk to the drives. The drives sport an HD 6301 CPU, which is the 6800 derivative, which has 128 bytes of RAM, 4K of ROM, and a UART built in. The board also has an additional 2K of static RAM and a custom gate array chip. If I had to guess, I would say that the reason for the low density of the drive and its odd design was to keep the cost low while still using a very common and modern storage media. Here is our pair of twin drives. I guess that would make these paternal twins, wouldn't it? They're nearly identical, but not quite. This is the TPDD1. See, it actually has a drive protector in here. And the case on these guys are exactly the same. Here is where you put in your AA batteries, and this has some dip switches underneath it. In the massively large 200K version, the TPDD2 looks exactly the same. These open in an odd way. Allow me to demonstrate. You press the eject button, and our disc, in this case the head protector, pops right out. You put your new disc in and push that down. I think that's kind of neat. Other than that, there is just a power switch and a low battery indicator. So we'll need to flip these over to get to the screws to start taking these apart and take a look at our belts. Well, I got my screwdriver set out. I double-checked the battery compartment to make sure that it's empty, and I noticed that there are 2 flathead screws in here, which are incorrect. So I think somebody's been in here before me, because normally all 6 of these are the same. Before I start taking stuff apart, I'm going to try to save myself a little time later by putting some tape on the buttons here to keep those from falling out when we take that front panel off. In my mind, I've labeled these screws A, B, C, D, E, and F, and we want to take out A and B first. Once we have A and B out, we can flip the drive over and lift up the top cover from the back. Try to sneak it out of here. This one's being cantankerous. There we go. This one does have a few breaks, like here, and there's some one right here too, so we'll have to take care of that later. So we'll go ahead and flip this guy back over, and then we're going to do E and F next. And then we'll try to slip that right off the front. So now we have the front cover off and our tape kept our buttons from falling out. Yay! You can see here we have a switch right here, which is our power switch, little LED. Now we'll flip him over one more time, and we'll take out these 2 flathead screws.
Yeah, my screwdriver got a little too excited. Okay.
Well, at least they put a similar sized screw in. It is completely the wrong threads, but at least it wasn't too long. So I bet they damaged the threads, but we'll have a look. Now we've got the drive mechanism loose, but we need to loosen up the power supply here. And notice on the power supply there's a couple plastic ferrules.
I'll set those to the side.
That is right. We've got to take this loose, the power switch, so we can get the whole power supply out. This just has 2 little Phillips head screws. Just right here. Now, try to get the power supply out of the way and get the drive mechanism out. There we go. And there is a little plug right here, which will free up that whole power supply. Easier said than done. There we go. Now we've got the mechanism and the power supply out of the bottom case. And here's our control board and the dip switches that we mentioned earlier. Notice this has an RF shield built into the bottom of this case. Now you want to be careful of this little ribbon cable right here, although it does have a rubbery feel to it. And we've got 4 screws holding our circuit board down. Okay, here is our microcontroller unit that we talked about that's 6800 based, and it has some built-in RAM and ROM and a UART. This looks like our custom gate array chip here, one with brother marked on it, and this is our additional 2K of static RAM. And these chips are just some CMOS glue logic. And then of course our dip switch. Not much to it. Alright, we have two cables we need to unplug here and here. These are different sizes and different places, so we can't get them mixed up. And it feels like there's a cable still stuck here. Oh yeah, this is the head cable probably. So for this head cable, we want to very carefully pop up the ears on this ribbon connector. They will go up till they latch. Then we can unplug that from the board. Now with this all spread apart like this, we can get to this last plug right here, which has the red wire going that way. I'm just going to use my screwdriver to carefully encourage it to come apart. That'll make it easier to work on each half of this. There's some belt stuck here and some belt stuck here. I got this set of tweezers from Amazon, and I've seen these sold under different names, and they were, I don't know, 10 bucks or something. It wasn't very expensive. So I'll use these to carefully pick these bits of belt off here. Okay, I got a piece of paper towel here to put the bits of squishy belt in. Okay, it looks like we got all our belt off of there. I'm going to go ahead and clean up the spots where the belt was touching the board with a little alcohol. Take our alcohol and wipe that stuff off the board and off the cable where it was at, and then we'll kind of inspect this circuit board. I don't see any problems that would make me suspect there was any battery leakage. Little flux from manufacturing process. You notice I'm holding these boards as a set, so I'm not putting any stress on this ribbon cable right here. Alright, now we've got to pick the rest of this belt off of here, a little at a time. It has the consistency of stringy chewing gum. I'm going to try some flat build pliers here. Maybe that'll help. Yeah, basically we're just scraping this off of there. Oh yeah, nasty, nasty, nasty. That's the consistency of that belt now. It's just tar. I probably used 10 or 12 Q-tips getting all that goo off the pulleys. I had to turn it up on the side like that and gently scrape under the edge, and I kept cleaning until the Q-tips came back clean. And then I took a few other Q-tips and I cleaned all the fuzz and stuff out of here, pushed the release button there, and cleaned everything up inside of there that I could see needed cleaned. I have my new belt here. Here's what that is. And just, oh, see, that's what you don't want to do. Don't do what I did. There. Come on, Jeffrey. I'm experiencing technical difficulties. Okay. Okay, there we go. Now our belt is tracking fine. Okay, now one last little bit of maintenance before we try to put it back together. You might notice that here and here there are a couple metal shafts and there's a worm screw right here. And these look like they had something like lithium grease on there, which is kind of common for a 3.5-inch floppy drive. So I've got a little on a Q-tip here. I'm just going to put a very, very tiny amount on the slides. Tiny, tiny, tiny amount on the worm screw. I'm going to try to rotate this around by hand. Just a little lubrication in the rest of the spots there. And I'm going to walk this back the other way. There we go. Now we've got it back to the resting position, or the home position, if you will. One last thing I'm going to do is go ahead and clean the head on this guy. So I'll pop him apart like this. You can see the head right here. This is only a single-sided drive. Just clean that a little bit. Clean that pressure pad a little bit. And that should be good. The tricky part about putting the board back on the mechanism is this ribbon cable. But if you pop the mechanism open like that, you can get a finger in here to push the ribbon down into the connector. Guiding that in with the screwdriver very, very carefully. And pushing with this finger to make it go down in that connector. And then we'll just snap it closed. I gave the cover a good wash and let it sit overnight, and I found this broken off piece of plastic in there, and as well as some cracks. So I'll take some acetone, which is in this syringe. I will apply it carefully to the part. And just stick it right in place and then hold it there for a few minutes. All in all, this cover is in okay shape. There's some cracks, there's some scuffs, there's a few little bits missing on corners and such, but it's functional. It's certainly not new though. And this will be hard to see. Right here there's a split, and on this corner this chunk is missing, but I can glue these other splits. Do this one from the inside. Ah, shoot, I got way too much on there. Rag to the rescue. At least that was on the outside too. Well, that oh well. Not everything always goes as planned. So I now have my fingerprint on the case permanently in acetone. Guess that can be a conversation piece. Oh, how stupid, Jeffrey. Okay, and I will try the same thing on this crack on this back edge here, and I'll try not to squirt it everywhere. I was just using the drill to hold this up for you. Now I've got to find the broken spot again. It's right here. Okay. If you do not flow out a gallon of acetone, it works quite well. I also noticed there's some cracks on these posts. So I thought what I would try to do is dribble a little acetone down the slot. Like that. That was too much. Gosh. And then squeeze it together with some pliers like this. Yeah, if you relax the pliers and squeeze a few times, it'll help draw the acetone into the crack. Then we'll do the same thing with this other cracked post here, and we'll set this aside for several minutes to cure. I did take the magic eraser to this spot where I touched the outside of the case with acetone on my finger, And unless you get the light just right and know where to look, you can't really see it anymore. So out of all the blemishes and marks on the case, that's probably one of the least objectionable. Let's go ahead and try to get this guy put back together now. Maybe we'll do it like this. We'll just stand it up on the edge and drop it. I'm really struggling getting that connector in there. We'll get the screwy driver to help us out. There we go. Now that's plugged in. Okay. Kind of hold the drive mechanism up and try to rotate the power supply around into about the right position. Just one of those jobs where you gotta hold your mouth just right. Welcome to the exciting Jeff fighting getting stuff back in a case channel. Where this mounting hole is, there's a post that sticks up from the bottom cover, and there's very little room to get that guy through there, and it's really a pain in the butt. With all of these plastic screws, it's always a good idea, or should I say not plastic screws, but screws going into plastic, to rotate the screw back until you feel it pop down into place and then go forward. That way the screw was always going back into the original threads. Okay. And we'll get this guy hooked up. I think before we put the top cover on, we'll test it out. This would have been a piece of copper with some conductive adhesive on it. So we'll do our best to get it stuck back down there where it goes. Getting your computer set up to talk to one of these drives is an interesting process because the computer wasn't built with a DOS and ROM, so somehow you have to load it on the computer. And you do that by using a special disk. There is one for the TPDD1 and TPDD2. And you type in a little basic program and you run that, and it downloads the DOS, which is this floppy.co, from the disk, and then you set the dip switches back, and then you're ready to go. Now, I've already done that on this computer, and if you want to know how to set that up, I will put a link in the description below to an excellent video by Josh Malone where he covers that process in great detail. So I'm going to take a 3.5-inch double density disk, not a high density. You want a double density, an 800K disk like you would have used on an Amiga or Atari back in the day. Yeah, there we go. Can't see what I'm doing. We'll put that in there, and we'll go over here and run floppy.co. So now I'm going to go ahead and format this disk. So I'll hit F7. Are you sure? Yes. It's going to say, hey, this contains data. And we'll say, yep, we want to go ahead and format it. We'll start from new. And it'll take a few minutes to format the disk. If we want to save a file, we'll hit F3. And the file name in RAM that we want to save is called hey.ba. And we'll call it the same thing on disk. And we saved our file. And now if we go back into the DOS menu and bring up the files, it'll show us that we have hey.ba in there. If we want to load a file, we can hit F2. On disk, it's called hey.ba. And in RAM, we'll call it something different. How about hey2.ba? And we loaded that into our RAM, and if we go back to the main menu, we can see that we have hey2.ba. Now let's get a new belt in this TPDD2. This comes apart pretty much like the first one. Get this head protector out of here, except when we get into the power supply section. So I'll just cut ahead toward then. The one thing I will try different on this one is popping this ribbon cable loose before I get the board loose from the mechanism. I think this will be easier in the long run. Get that loose. Pop that up. And we can just gently pull that ribbon cable out. Easy peasy. As I have been working on this, bits of the belt have been falling out and getting all over my hands, making a real mess. Take off the front switchboard, just like we did before. And we've got 2 screws here for the power supply. Only one of them this time has the ferrule on it. And similar to what we did before, we need to sneak the pair of these out of the bottom cover. There we go. Oh, more belt. What a mess. Okay. Only this time the power supply comes unplugged like that. And there is some belt in the bottom of here. And then next thing we need to do is take the shield off the bottom of the mechanism. You notice the shield's not in the bottom of the cover anymore, it's actually on the mechanism. Now on the TPDD2, the RF shield's on the bottom here. There's 3 external screws and 1 under the shield. Okay, now we can take the shield off. And there's our hidden screw. Before we do that, let's go ahead and get these connectors loose. And notice these are in the same spot as the other board. And we have the same basic components. We have our processor, our microcontroller, RAM, the GAL, our glue logic, but this is new. That is a BA6580K. And all 4 of the shield screws are the same. And I've already taken the ribbon off here, remember? And the same way on this one, the red wire goes forward. There we go. And this one has some belt stuck on it too. But as you can see, the rest of the mechanism is the same, so it's the same procedure of cleaning off the old gooey belt and then putting a new one on. Well, we have a little unexpected fun. You might be able to make out the green crusty stuff on top of these caps. And the circuit board itself is not too bad. There's nothing on the bottom. You can kind of see a little of the mess right here, and you may have guessed already. That's from the battery compartment. So, what I'm going to do is put a little vinegar on the stuff to start with and let it set. Try to neutralize what can be neutralized, and then we'll pull those caps off there and replace them, and hopefully that's all we need to do. Well, we got kind of lucky. I pulled off all the components I couldn't see under, including these 2 caps, this inductor, and this little cap here. And it looks like these 2 caps and this little one right here are the only place where there's really any corrosion. So I'm going to go ahead and replace these 2 caps. This one really wasn't too bad, so I'll just clean that up. And this inductor was fine, and I'll touch up the solder joints on these surrounding components with a little flux and reflow those, and then this should be as good as new. The circuit board cleaned up nicely. I reflowed all the joints around there, replaced the inductor and this capacitor. I ordered a couple of new electrolytics, which are about the same diameter as the original. They're the same voltage and capacitance rating. They're just a little shorter, which is fine because there was no room for longer ones under there. So if I can do this on camera, I'll just pop these guys in here and give them a new home. One side of each really quickly. Push up from underneath to make sure they're seated up against the board. These are going through some thick traces, so I'm keeping my iron on there for 3 to 5 seconds. There we go. I'll get the other two. There we go, some fresh new caps. So then I'll trim these off and we'll pop this all back together and see how it works. I did go ahead and put our cover back on here. Remember, we've got the one hidden screw right here, so I find it easier to start that screw in and start one of these other screws in with the shield off, just to get it in position, tighten this hidden screw, and then put the shield on. I also went ahead and got the power supply set roughly into place and plugged in our little battery connector here. And of course, I've also already cleaned up the battery contacts. And we need to plug this into here. There we go. And I'll kind of slip everything into place. Like this. Much easier than the TPDD1. Another thing I did is, after I got the board on, I then popped this open and inserted the ribbon cable. It's a lot easier to do it with the board in place than when you've got the board dangling there. This one only has the one screw with the ferrule. And I'm going to start just the two screws that hold the mechanism down before we test it. The owner of this already put a sticker on here about when the belt was replaced. Well, we're not quite so lucky with our TPDD2. I deleted our DOS for the TPDD1 off the computer, and I typed in the simple one-line basic program to bootstrap the TPDD2. And if we run it, it does nothing. The drive doesn't do anything. The computer's just sitting here. And if I do a shift break, it shows an I/O error. Let's unplug the serial cable, and we'll try it again. It looks like the same thing. Same error. I tried the cable I used for the TPDD1, same thing. So it looks like our drive is not talking back, so we'll have to dig into that some more. I pulled the power supply back out, and unfortunately it is worse than I originally thought. You can see I pulled off more components on this side. I did the same over here, these capacitors. There was nothing under here, so it looks like all the damage was this way. And this is a transformer. You can see it's got multiple leads. One of them actually pulled out, but it went to a pad that was not used. So hopefully it wasn't wired anything into the package. There's another inductor here. It was also quite nasty. So I'm going to clean this up, and I'm hoping that this transformer is still good. Well, after a lot of cleaning and soldering and cleaning again, I did get the power supply working. I wound up having to replace that funky ribbon cable type thing that was here because it had a break in it going to the power switch. So I just used a piece of regular ribbon cable on that, soldered that in there, and I spent quite a lot of time going through this trying to figure out how the power supply worked and what all the signals on this connector were so I could make sure that they were all working properly. And luckily in the back of the user's manual there was a schematic. There was even a schematic of the power supply, which was very helpful. And then I made my own list of what all the different pins did. And these two change states when it's in a low battery mode. This is the battery voltage. The control board sends out a power down if it's been on too long without doing anything. The control board sends out an alarm to light the LED, that type of thing. And so I was able to find out that all this worked. And I was trying to, with everything on the bench here, plug it into the drive and make sure the drive was working. I was having problems with that. And I kept going back through the power supply, and I finally realized I was so fixated on this power supply because there was a problem there. I got so fixated on the bloody power supply that I was completely missing the fact that I was trying to bootstrap the drive incorrectly. I wasn't following the directions completely. So I'll get this put back in the case now, and we'll go through the bootstrap procedure, and I'll show you where I was messing up. Alright, I'll show you what I was doing wrong trying to bootstrap this. I've completely reset the computer from when we were using it to test the TPDD1. I've got the bootstrap disk for the TPDD2 in this drive. The drive is off, and I've entered the one-line bootstrapping program. I will run it, and it looks like it's kind of locked up. And I will turn the drive on, and then it'll load the bootstrap program. And now it's loading the file manager, and there we go. That was pretty fast. Now we have floppy over here. So I'm going to take that precious bootstrap disk out of there, and we'll run the same sort of test we did on the other one. I've got this one write enabled. I'll go to our DOS program. We'll choose to hit F7 to format a disk. We'll say yes. It's going to tell us that it has something on it. We'll say yes. And this will take a little while, but it will format the disk for us. And we were able to format. Hit F3 to save a program. And here, this version of the DOS is a little nicer because it actually shows you what programs you can save. So we'll save, we want to save IPL.PA. And we'll call it the same thing on the disk. And that worked. And then we can ask it to look at the files. We can see that file's on the disk. So if I go back to the basic and I tell it to kill IPL.BA, we go back to our menu, it's no longer there. So we can go down to our floppy control program, F2 to load, and we'll tell it we want to load IPL.BA. And we're going to call it the same thing in RAM. Okay. We'll go back to our main menu and see we have it back in basic now. So we've got both of these drives working. Now we need to put the covers back on and put all the screws back in. And I think that'll be it. I did want to show you the advantage to taping these buttons on this front cover is it goes on really easy. We tape this on there with the switch down, so we'll make sure it's down. And it just pops right on. Like that. Very, very easy. Now we just need to put the screws in it. Well, I hope you've enjoyed this look at our Tandy Portable Disk Drive 1 and Portable Disk Drive 2. We had different challenges with each. Both needed the belt replaced, and those get gummy and messy, and they're just a little nasty to clean up. With this one, we had some cosmetic challenges, and I didn't help things out by squirting acetone all over my finger. But that cleaned up pretty well. You can hardly see it anymore unless you know where to look. With the second one here, we had the power supply challenge from the batteries leaking, and eventually we got that sorted out. And I did get kind of led down the primrose path by fixating so hard on the power supply. I missed that even after I fixed the power supply, I wasn't bootstrapping it right. And that's really easy to do, and sometimes you just need to step away and do something else and it'll come to you. I know I had to read the directions several more times after I took a break before it dawned on me what I was doing wrong. But in the end, we've got them both working, and maybe they'll last another 30 or 40 years. I would like to take a moment to say thanks to everyone who supports the Hey Bert channel through Patreon and other means. It's greatly appreciated and you help keep the channel going. If you'd like some information about how to become a supporting member, just look down in the description box below and you'll see some links there. Also, thanks to everyone who subscribes to the channel. It's really encouraging to see that subscriber count, grow slowly, week by week. If you haven't subscribed yet, if you look down below, you'll see a rectangular box that says subscribe. Well, you know what to do. Just click on that guy and then click the bell-shaped icon, and YouTube will let you know just as soon as I post a new video. If you have any questions or comments, just leave them in the comments section down below. I would love to hear from you. Well, until next time, bye.